resulting from seismic loads or vibrational load. Seismic loads or vibrational load. Okay, so last day we or last to last classes we see that the load due to the wind, and as a result their stress on a self-supported vertical tall vessel. Today we will see how to calculate or estimate the stresses induced in a tall self-supported vertical vessel due to the vibrational load or the seismic load. Now, if I again draw a column, tall vertical column, okay, so vertical column, and the total height we can say this is h. Now, the seismic load is assumed to be distributed in a triangular fashion. That means if the foundations or the basement vibrates, then the effect of the vibrations will be increased from bottom to the top. So, at the bottom of the tall vessel, okay, the vibrational effect will be somewhat feeling less than that the upper portion. So, it is assumed that if the seismic load is distributed in a triangular fashion. As per example, in a tall building, okay, those who are staying at the top floor will experience more vibration that compared to the person who is staying at the ground floor. So as you go up, the load, okay, the distributions of the seismic load will be more. Now, so minimum at base and maximum at top. No, it is a general experience. Now, it is a vibrational load. It is a vibrational load, and it produces horizontal shear in self-supported tall vertical vessel. Now, Since you see here, since the load is distributed in a triangular fashion, so it can be assumed, okay, it can be assumed that uh, it is acting, okay, instead of this distribution force, we can assume that this seismic load is acting at a point two-thirds from the bottom of the vessel. So if it is so, it is the two-thirds distance from the, suppose this is the two-thirds from here, from the bottom. So this is the two-thirds of H. Okay, so we can consider it as a uh, concentric load rather than the distributed load at the height of the two-thirds. Here the seismic load is acting. Okay, so for our calculation simplicity, and the load can be estimated as, and the load can be estimated as seismic load can be estimated as F equal to seismic coefficient multiplied by the weight of the vessel. W equal to weight of the vessel, and SC is nothing but the seismic coefficient. Now, this seismic coefficient, okay, is a function of intensity, okay, how fast it is vibrating, and the period of vibrations, the time of vibration, period of vibration. So depending on this, the coefficient value may varies. Okay, it may varies from minimum to moderate to maximum. As for example, it can have value of 0.02 for the minimum, 0.04 moderate, and 0.08 as maximum. Now, so due to this seismic load, okay, what will happen? It will happen, bend it, and a horizontal shear will be produced. So the bending moment equations, okay, since stress induced due to bending moment up to height x, okay, this is not cross, up to height x from top of the column of the vessel is. So here we are considering from the top of the vessels. Okay, suppose this is the x distance. So we are taking here the distance considering from the top. So x equal to 0 at the top, x equal to h at the bottom. Now it can be, the bending moment can be written as at any level x from the top, is nothing but the SC seismic coefficient into weight into the x square divided by 3 into 3h minus x by h square, total height square. So you see, this is the equation for the estimation of the bending moment. Now, so when the bending moment will be maximum, rule number 4. So at what position the bending moment will be maximum?
At the top, sir.
You
Uh, Sir,
you
because
just follow you first just follow the equations. If you at top, what is the value of the x? X equal to at top, what is the value of the x? X is the variable here. So what is the value of the x at top of the column? Hmm? Hello.
hello, hello. Am I audible,
हाँ
sir?
बोलो हाँ audible बोलो.
Sir, then that will be zero, maybe.
Zero may why maybe we are considering the x starting from the top.
Okay,
So
okay,
at
okay, sir. Then zero. Okay, okay.
so it will be 0. So the bending moment is 0 at the top and highest at base. So when x equal to h, that is at the base, okay, the bending moment is b. Will be, if we do the simplifications, it will be SCWH. Okay, so this is the maximum bending moment. So similarly, you know, this is the tree. It is our experience. So if there is too much turbulence in the air, wind, so there is a vibrations, okay, in the branches of the tree, and due to that a bending moment is created, and when the tree falls it is maximum from the bottom. Okay, it never falls from the top. Okay, it is not, but from not here also. So since the bending moment induced at the bottom is maximum due to the vibrations, due to the turbulence in the air, so tree is bending from the bottom. So that's why similarly when the column under the vibrational load will collapse, it will collapse from the bottom, not from the top. Okay. So the equation also agree with that conclusions. And what should be the bending stress? So this is the bending moment. So therefore the bending stress. So the bending stress is four of MSX divided by pi d naught square into T. So this is the bending stress. And what is the maximum value of the bending stress? What is the maximum value of the bending stress? That is the bending stress maximum. Okay, bending stress maximum. So it will be we know the maximum bending moment. Okay, so it will be the value of two-third of SCWH divided by the pi r square. So that's why we are not putting 4 here. Pi r square into t. On simplifications, it will be two-third of SCWH pi r square t. So this is the maximum bending stress due to the seismic load. Okay, now our consideration is there. What is that? Now, suppose this is a column. Now, it is considered that if there are both wind force, okay, acting on the column and the seismic force is also there. Suppose they occur at a or simultaneously seismic load. So we will consider the only one effect, either of the effect, either wind effect or the seismic effect on the column, because and who those value is greater or more, you will consider that value only, because the possibility of wind load and the seismic load acting simultaneously over the column is rare. So that's why we will calculate the both. We will calculate the both loads separately, and whichever is more, whichever is more severe is used to calculate is used to calculate the maximum resulting stress. Maximum resulting stress. So we will calculate separately both wind stress or seismic stress, and we will consider which one having the greater value or greater impact on the column, and we will consider that value only. So we can write, if the stress due to the wind or seismic comes to be the tensile, so maximum or resultant stress, resultant stress at the bottom, at the bottom of column is the, if it is tensile, then it will be stress due to the wind force, or we will consider stress due to the seismic force, whose value is more we will consider. plus, sorry, not plus, minus the stress due to the dead weight. Because why minus? Because dead weight is always compressive. Or we can write also, if it is compressive, then we will calculate separately the wind stress or the seismic stress separately. This is or, not minus, plus dB, because it is also compressive. So their effect will be additive, and here if these two forces are tensile, then the dB will be the subtractive. So this is the process to calculate the compressive or tensile stresses calculation due to the seismic and wind load. So this is the process. Simple. We have to find the total load, and from there this is a well-known formula for estimating the bending moment, and from bending moment to we will calculate the bending stress divided by the area of the supporting. So these are the convention.
Hello,
Another, bolo,
sir.
hello.
At the maximum bending stress maximum, you forgot to multiply with 4.
No, 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 no. You see here, here, no. Here I am using r squared, not diameter square. It is radius. Here I multiplied by 4
Okay,
because it
sir.
is this square. Okay. So d square
Yes.
by 4 is nothing but the r square. So I put it here as r square. Okay. Now, another is that we will calculate the stress due to the eccentric load or the eccentricity of loads. So now next is the stress due to eccentricity of loads. These may be also tensile in nature or compressive in nature. Tensile or compressive. Okay, actually what happens, you see, with every vertical or even horizontal, here we are discussing the vertical because this load applicable for the vertical column. So there may be some piping. Okay, there may be some piping here, here also. The length may differ, diameter may differ. Maybe there is some platform for the standing and cleaning purpose, or other offset piping may be there. Maybe there are reboiler. So all this attachment with the main column tries to bend it. Okay, so a bending stress is produced if there is a heavy iron platform and there is a ladder considered. So it has also a considerable weight for this platform. So it will try to bend in this direction. Again, there is a pipe or a reboiler is there. So it will try to bend it in this direction. Okay. So there are some eccentric loads essentially are there. So and they are individually try to bend it to their resulting direction. So that's why we have to consider these eccentric loads also. And It is very easy for the calculations. What is the eccentricity? The eccentricity is calculated by the equations E equal to summation of ME divided by summation of WE. Then what is the meaning? What is the physical meaning of this eccentricity? Okay, so this eccentricity, then physically we mean the distance from the column axis. So the column axis is this one. So the distance from the column axis to the center of resultant reaction. Suppose there are different attachment and they are individually try to bend to their directions. So there will be a overall direction or overall resulting reaction. So from the column axis to the center of the resulting reactions, the distance is known as the eccentricity. And what is the meaning of the summation of ME? M for bending moment, you know. So what is the meaning of the summation of ME or how to calculate it? Summation of ME is the summation of moment, summation of moment, summation of moments of eccentric load, of eccentric loads. So you see here, there is a bending moment due to this ladder. There is a bending moment due to this eccentric load platform, piping. So all we have to calculate. So individual bending moment and their summation is nothing but the summation of AB. And what is WE? It is easy. It is nothing but the summations of all eccentric load of all eccentric loads means their weight. So we can calculate it by WE1 first eccentric load into E1 to the distance between the center of the axis to their reaction plus WE2 into E2 plus WE3 into E3 so on. And what is the WE? WE is the nothing but the summation of their weight. WE1 plus WE2 plus WE3 plus dot 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 dot. So this is the equation. So we now know what is the eccentricity. Now we have to calculate the stress. So what are the stress? The additional or the stress, the bending stress, at plane x caused by the moment, bending moment, whatever is. So what is that? Is nothing but okay. Or sometimes we can also write it like 4 summation of me divided by pi t d square also, because the ratio of di and the thickness is very small, so the negligible effect. So if the t value is not given, so we can also estimate by simple the mean diameter. Anyway, so these are the effects for the seismic load on a self-supported tall column, and the effects of the eccentric loads, that is different attachment on the tall column, is this. So we now already know different loads or the different stresses induced in a column. First, we know the stress induced by the internal pressure. Two type of stresses are generated. One is the axial and second is the circumferential. Next, we discussed about the combined loading. Combined loading means taking care all the loads acting on their, may due to their dead weight, due to the offset piping. Okay, and individually we also estimate the different loads. Loads due to the wind, loads due to the different dead weight, okay, its own weight, different equation, different derivations we have done, and further loads or stresses induced due to the seismic load and the eccentric load. So all type of loads we have discussed that can be induced stresses on a tall self-supported vertical column or pressure vessel. So this is for today. Next day we will do or solve some problem based on our previous classes. Okay, ठीक है? Anything? So next day we will do some problem.
Hello, sir.
हाँ बोलो.
Sir, in that seismic activity case, we would know that the stress due to wind would be compressive, but stress due to that seismic activity, will it be positive or negative? How will we know that?
Okay. So where is the expression for positive or negative? Yes,
Sir,
yes. You see here, it is simple. I already told in few class ago. So this is a tall pressure vessel, vertical, and this is the thickness of their shell. Okay. Now, if it bends like that due to the wind, and from the top, From here it breaks. So this is the center line. So the portion of the cell of the right side of the center line will be in compression when it breaks, and the left portion of the cell wall will be in the tension. Is it clear? Definitely, if it bends, so this material, okay, or the thickness or the wall of the container or column, this side will be in compress, and these portions will be in tension. So it will be like that under the, so it will, here it is the breaking point. So definitely this wall must be compressed, otherwise how can it be bent like this? And similarly, this portion of the column should be try to increase their length, so that portions with reference to the center line of the column will be in tension. Here is tension, here is compression. Otherwise it can't break. Okay, if you break your pen, okay, you just try to break your pen. So in the directions of the breaking, so that portion of the wall of your pen or the material will be in compression, and the opposite portions of the bending side will be in tension. So if in a problem, if you given the allowable compressive stress value is this A, kg per centimeter square. Okay, so in that case, you have to calculate, okay, you have to calculate based on their compressiveness of the stress value. Suppose a material, okay, you are going to design the available compressive stress is given. So in that case, you have to find the compressive stress of the due to wind or the seismic. You have to take the higher value of that and with the addition of their dead weight. If any problem, it is given that the tension, allowable tension, okay, is given as B kg per centimeter square. Then we have to calculate the tensile stress and have to minus the dead weight. Okay, because sometimes depending on the material, these two stresses not essentially equal. Compressive stress and tensile stress not may not be essentially equal. Okay, a material can be broken easily under tension, or some material can easily be broken under compress. Okay, if you keep some force or hammering of a cast iron, that will break easily. Okay, but if you hammering a steel, it will not break. So it depends on the material you choose, and depending on that, that may be failure due to the compressive or the tensile force, and based on that we will calculate its design for the thickness. So that's why if it is given the allowable compressive stress, so you have to calculate the stress, compressive stress due to the wind force and the seismic force. The equation is same, and add with the dead weight, and then go for the thickness finding. So it's that's why these forces due to the these stresses may be tensile and the compressive, wind stress and the seismic stress, because a column, when a column breaks, so one side of the cell material will be in tension and another side will be in compression. So that's why depending on which side we are going to consider for the design purpose or the safety purpose, we have to consider that stresses. ठीक है? Anyone?
Yes.
So
Yes.
next day we will continue with some problem. ठीक है?